we started with alpha i's being uniform, the same for all data points, 1 over n, and now we want to change them to focus more on those difficult data points where we're making mistakes. So the question is, where did FT make mistakes, or what data points FT got right? If FT got a particular data point xi right, we want to decrease alpha I because we got it right. But if we got xi wrong, then we want to increase alpha I so that the next decision stump or weak classifier homes in and does better in this particular input. Again, the AdaBoost theorem provides us with a slightly intimidating formula for how to update the weights alpha I, but if we take a moment to interpret it, we'll see that this formula is extremely intuitive and does something quite nice. So let's take a quick look at it. So it says that alpha I gets an update depending on whether FT gets the data point right, so this is correct, or whether FT makes a mistake. And as we'll see, we're going to increase the weight of the data points where we made mistakes, and we're going to decrease the weight of data points we got right. So let's take a look at this. So let's take one xi, and let's suppose that we got it correct. So we're in the top line here, and notice that this equation depends on whatever the coefficients do assign to this classifier. So if the classifier was good, we're going to change the weights more, but if the classifier was terrible, we're going to change the weights less. So let's say that the classifier was good, and we gave it weight 2.3. So what we're doing here, we're looking at that formula, we're multiplying alpha I by e to the minus w hat t, which is 2.3. And if you take your calculator out, you see that this is 0.1. So we're taking the data points we got right, and we want to multiply the weight of those data points by 0.1, so divided by 10. So what effect does that do? We're going to decrease the importance of this data point of xi, yi, so this particular data point. Now let's look at the case where we got the data point correct, but the classifier that we learned was as good as random, so we had weight 0, just like we discussed a few slides ago. So this kind of overall weighted error of 0.5 leads to weight 0. In this case, we're multiplying the coefficient alpha I by e to the minus 0, which is equal to 1. What does that mean? That means that we're going to keep the importance of this data point the same. And that also makes a ton of sense. So this was a classifier that was terrible. We gave it a weight of 0, we're going to ignore it. And so since we're ignoring, we're not changing anything about how we weight all of data points. We're just going to keep going as if nothing's happened because nothing's changed on our overall ensemble. Now, let's look at the opposite case when we actually made mistakes. So let's say that we got xi incorrect, so we made a mistake. In this case, we're in the second line here. So if it was a good classifier, they had a w hat t of 2.3, then we're going to multiply the weight by e to the power 2.3. So this is e to the 2.3, which, if you do the math, is 9.98, so approximately 10. So it's 10 times bigger. And so what we're doing is increasing the importance of this mistake significantly. So the next classifier is going to pay much more attention to this particular data point because it was a mistaken one. Now finally, just very quickly, what happens if we make a mistake, but we had a random classifier, they had weight 0, we didn't care about it, so the multiplication here is e to the 0, which is again equal to 1, which means we keep the importance of this data point the same. So very good. We've now seen this cool update rule from AdaBoost, which makes a ton of sense. It increases the weights of the data points where we made the mistakes and decreases the ones we didn't make mistakes. Extremely intuitive, and we're going to use it in our AdaBoost algorithm. So if we update our algorithm, well, we started with uniform weights. We learned classifier f of t. We updated its, we computed its coefficient w hat t. Now we can update the weights of the data points alpha I using the simple formula from the previous slide, which increases the weight of mistakes, decreases the weights of the correct classifications.